to the like temperature part. So I hope some of you have already done this kind of thing. So we will be doing the like monitoring the health conditions because of this pandemic. So everywhere you go, you need to just like your temperature is the first thing that is getting measured. So we will do like uh, go on. That's why we will go into that temperature monitoring thing. So let me share with you the screen so that all of you log in into your Tinkercad account. Just go to the web browser. My screen is visible, right, everybody? All of you can see my screen.
Yes, ma'am.
Okay, log in into your Tinkercad account. Just Google login Tinkercad, and all of you already have the account, so just quickly log in. Okay, do all of you log in? Just raise your hand after you log in. After
Ma'am,
you
can we
log in.
log in with our personal email ID, or
Yeah, yeah.
is it necessary to do with VIT one?
I think you can use your personal. You already have an account, right? It is
No,
so.
no, ma'am, I don't have account. There is an option that we can log in with the help of Google account. So I have a Google account. So I logged
Yeah,
in
you
using my
can.
personal ID.
Yeah, yeah. No issues, no issue.
Okay, ma'am. Okay,
You can use any of the accounts.
okay, ma'am.
Just remember it. Like your system. Anyway, your system will be fixed. So either save the password or remember whatever you are using. So that during exam also, if you get, at least you are able to log in.
Okay, ma'am.
Okay. So let me see how many of you have logged in. Just 10 of you. So those who have logged in, raise your hand. Okay. 15. Aditya, any issues? Not logged in yet. Okay. 19. Those who have logged in, just raise your hand. And if anybody is facing any issues, let me know. Twenty-nine. 31 of you. Shobin, any issue?
Mine
Log.
is no issue. I already logged in.
Yeah, yeah, logged in. Abel, logged in. Amartya,
Yes, ma'am. Give me, ma'am.
yeah, logged in. Or any issue? Yeah, logged in. With those who have logged in, just raise your hand so that I get to know. Chitnes Raj Abhay, logged in. Yeah, Chetan Jain, Firal. Yeah, Firal, any issue? Why you have not yet logged in? Kasam Sai Vardhan.
Yes, ma'am.
Yeah, yeah. What problem? Any problem, Firal?
No, ma'am.
Okay. Is it have you logged in yet or no?
It is loading, but I'm trying now.
Ma'am,
Okay. After you log in, just yeah.
ma'am, I
Tell
don't
me.
get which website should we log in?
Tinkercad.
Uh,
Tinkercad login.
using a
Tinkercad.
credentials, ma'am.
Sorry.
using your VTOP credentials, ma'am.
No, you already have Tinkercad you have used, right, priorly in the previous semester.
No,
So
ma'am, I
you
haven't used it, ma'am.
okay, anyway, just use either your Google account or your BIT mail ID. It doesn't matter.
Okay,
Just
ma'am.
create,
Okay.
create and log in.
Okay.
In the previous semester, didn't you do experiments with Tinkercad?
No, ma'am.
No, ma'am.
No, ma'am. With ThinkSpeak and IFTTT we have done.
Okay, no issues. This is very user friendly. It can be an issue. Yeah, Sanjit. Sanjit.
Yes, ma'am. Login. Yes, ma'am. Logging in.
Okay. Kasam Sai Pardhan. Chetan, can you hear
Yes,
me?
ma'am.
Yeah, what logged in, right? Okay. We Risivardhan.
Yes, ma'am,
Yeah.
I'm logging.
Okay. Log in. Okay, 48 of you have already logged in. So, so it's majority. So I'll just go start moving in. So what you can see is on the left hand side you have this panel, and you have this circuit section here. So get into that section, and you will get a create new circuit. Okay. So all of you just log in into that. Click that create new circuit. Yeah. Do you all get? Could you all go into that create new circuit section?
Yes, ma'am.
Okay. So you can see on the top you have something written here. Like I have this tremendous something go over. You might have something else written over here. Can you see on this left hand
Yes,
corner?
ma'am.
Yes, ma'am.
Okay. Just click on that and edit it as per our experiment. So what we are doing, we are monitoring the health condition of a patient using temperature. Okay, like if it is above a threshold, we will try to give an alert, and if it is below a threshold, we'll give like it won't be alerted. Like some other color, the LED will glow some other color, and if it is above the threshold, the LED will glow red or something. So what you do is just give it a name, health monitoring, any name. It doesn't matter. This is for just for you to like understand that this is the health monitoring using temperature. That is what I am doing. And click. Okay. Is it done till now?
Yes, ma'am.
Hello. So in this experiment, basically what we will be using is we need a breadboard, okay, an Arduino. So what we will begin with is we'll drag and drop a simple breadboard here. You can drag from this right hand side panel to this. Could you all drag and drop? On the right hand side, you can see all these basic circuit elements. So drag this and drop here on the workspace. Could you do this much, everybody? Hello. Okay.
Yes, ma'am.
Next is we need this Arduino also. So drag and drop this Arduino here also. Okay. So this is all, like we need a breadboard, we need a connection with the Arduino, and we need what I told, we will be using an LED. Okay, the LED, if it is above a particular threshold, like suppose the thermometer, whatever you are like using while entering the institute or the shopping mall or wherever, if it like it is above a threshold, the like you will be indicated that you are above a threshold, you are not allowed or something. So that way you will put an LED here. Okay, if it is above the threshold, it will glow red, and if it is below, suppose we are measuring the temperature in Celsius. Okay, so the normal is 36, okay, around 36 degrees Celsius. So if it is above 36, so till 38 degrees Celsius, that is it will be indicated that you have mild fever, and if it is above 38 degrees Celsius, that indicates you have very high fever, and if it is below 36, it's normal condition, you won't be like stopped. So that's all we will do. So what I'll do is, here I can just search LED. So RGB LED. Okay. So you can see, drag and drop this LED RGB. Just see there are 4 terminals here. Okay. What is this RGB LED is? You have three terminals, one for red, green and blue, three different terminals, and the fourth one is for cathode. Okay. Just drag and drop this RGB LED here on the breadboard. Is it clear till this much?
Yes, ma'am.
Okay. Next we need a temperature sensor. Okay. So we need a temperature sensor. So how to go, that is a temperature sensor. Just write TEMP. The moment you write, you will get this temperature sensor. This is TMP36 sensor. So what I can do is, I can just drag and drop anywhere here. Okay. So it has 3 terminals. What are those terminals? I'll explore. As we move ahead, I'll tell you. So till now, is it clear? Till this much, is it clear? Okay. Have you done till this much, everybody?
Yes, ma'am.
Okay, next. So remember one thing, whenever in circuits you use LED, that means you need some resistances to control the flow through the LED, or else your LED will burn. So obviously we need resistances here. So the moment you write register, you will get this one. So what I'll do is, I'll put 3 resistances here. So I'll tell you exactly where I'm putting. I hope all of you already know about this breadboard voltage the potentials. So just see here. I've just zoomed in. You can see 1, 2, 3, 4 written along this, like vertically along all these columns. So this one indicates, the moment I click here, there is a green line getting connected to all the points. That indicates all of them are in same potential. This entire second column is in same potential. This is in same potential. So that's how the like connections are done in breadboard. So here, see here, the moment I click here, so the endpoint here, this entire line is in same potential. Okay. So what I'll do is, if I do a connection, connect the resistance here, that indicates this point is same as this point. Okay. So you can see this is the red terminal of the LED. Can you see this much? The moment I make the cursor here, you can see red written there.
Yes,
Everybody?
ma'am.
Okay, just move your cursor a little bit. What is written here?
Red and cathode.
Cathode. So that is the cathode terminal of your LED. Okay, just move one more. It is blue. Okay, next is green. So this red, blue and green are the actual terminals of the LED, and this is the cathode terminal. Okay, so I need not make a connection of resistance to this cathode terminal. So I need two resistances to be connected here. Is it clear? So
Yes, ma'am.
one more resistance I'll drag and drop here. Okay, and one more I need to drag and drop here. But the like if I put here, no, there is this like overlap. So what I'll do is, I'll just put here and I'll make a connection here. I just made it. Is it clear? Could you understand what I did? Yeah, could you understand what I did?
Yes, ma'am.
Okay,
Ma'am, can
so
you repeat the connection
Yes,
part?
ma'am.
Yeah, see this red LED has 4 terminals. Okay, this is red, this is cathode, this is blue, and this is green. So it has 3 terminals and a cathode. So I need resistances to be connected to those specific 3 terminals, not the cathode. So which one is my cathode? This one. So this second point. So I won't connect any resistance to this second point. Rather, there will be 3 resistances connected to the other 3 terminals. So already you know that in breadboard this entire thing is in same potential. So instead of connecting the resistance here, I can connect here because this indicates this entire line is in same potential. So this can be directly connected here. Then again one more resistance is connected to the other terminal and the third resistance needs to be connected here. But while I was putting here, I just saw that it is overlapping with this one. So just I kept it here and I have sorted these two. Is it clear? Yeah, is it clear or no?
Yes.
Yes.
Okay, just one second. I think somebody has messaged regarding some. Who is this one? People are just writing, I am not added in the team. Surya. Okay. We add Surya to the team. Okay. This is it. Okay. So that's all right. So I simply connected the LED and the 3 resistances. Clear till now? Is it clear till now?
Yes, ma'am.
Okay. Now just see this temperature sensor. Okay, let me show you this temp. I just brought it a bit down so that it is visible. Okay, just see this temperature sensor. See, here is the power terminal, here is the V out, and here is the ground. So this is the basically positive, and this one is the ground, and this one is the output. Okay, that's all how the connection should be. So I will make all the connections, necessary connections now. So let me just see. Okay. So here what I am doing is just a second. This. Okay. Now in this Arduino, just have a look. There are 4 sections. One is your power section, one is your analog section, one is your the digital, this entire section. Okay, digital section. This is the analog input, this is the digital input. Okay, and there in the power section you can see a 5-volt supply followed by the ground and all V and everything is there. And in the analog pin there are 6 pins. Okay, analog input A0 to A5. Okay, so now we will go for the connections. So what you need to do is first just see here there is this 5-volt supply. So this 5-volt supply I'll make connection to the breadboard. 5-volt supply I'll make connection to the breadboard. So where to make the connection? So in the breadboard you can see at the bottom there is this positive written here. Okay, so I can connect it straight away that. So the moment I click here, there's this edit window comes. So since this is the power like connection, we'll make it a different color so that it is easier for us to identify. It is like I'm edited red color. Clear till now? So this is just the power supply, 5-volt supply connected to the breadboard. You can see the plus written here on the breadboard. So I have connected this 5-volt here. Is it clear? And in the breadboard, I hope you know the moment you click here, you see this horizontal line that is getting highlighted. That indicates This entire section is horizontally at same potential. But here these are vertically at same potentials. But this one is horizontally at same potential. Clear till this much? Yeah, everybody clear till this?
Yes, ma'am.
Okay, next. So we made the 5-volt supply to this breadboard. Next, there is a ground terminal here in the Arduino. So just click here and make the ground corresponding ground connection. Okay. Where is the ground? This one is the ground. So I can just for differentiating it from others, I made it a suppose black color. Clear till now? Hello. Clear till now?
Yes, ma'am.
Okay, next. Surya, have you joined?
Yes, ma'am.
Okay. Okay, what we did, let me just tell you. We logged in into Tinkercad. Okay, and then simply dragged and dropped one breadboard and one Arduino. In the our experiment today is about patient health monitoring. Okay, so health monitoring using temperature. So I have kept a breadboard and a Arduino. Since it is a health monitoring using temperature, so I have kept a temperature sensor here. So this is the temperature sensor. Simply type TEMP here. The moment you type, temperature sensor will display. Just drag and drop here, and the LED here. Okay, this LED is a RGB LED which has 4 terminals. So LED connection has to be done means there has to be resistances associated, or else your LED will burn out. So to the 3 terminals, see this is the cathode terminal of the LED. So excluding that, the other 3 terminals are connected to the resistances. Okay. So this terminal is at same potential as this. So here one resistance I connected. Here again I get one more resistance I connected, and here again one more resistance I connected. Okay. I have just sorted this because there was that overlapping happening. So and next the 5-volt supply was connected to the positive of the breadboard, and the ground was connected to this negative, this potential of the breadboard. Okay, so we'll move ahead next. So now come over to this temperature sensor. Okay, so there are 3 terminals. One is your power terminal, one is your V out, and one is your ground terminal. So this ground terminal means I can simply make a connection to the ground potential here. And here what should be the color? I can make it black just to make like differentiate it from the others. Clear till now? Hello.
Yes, ma'am.
Okay. Next, the other terminal, that is this one. Just check. This is the power terminal. So here I can make a connection to this positive, and I can make it a red color. Done? Done till now?
Yes, ma'am.
Yeah. Okay, next. What is the third terminal of this sensor? This is the V out. So this we need to connect to the Arduino, because this is the output terminal of the sensor. So I make a connection to this, suppose A1 terminal. Okay, so this A1 terminal I can easily make a connection. Okay, so these 3 connections we made. Okay, one is your like 3 terminals of the, one is to the ground, one is to the positive potential 5-volt, and the other to the A1 terminal of the Arduino. The temperature sensor connections are done. Next is we need to make a connection to the LED. Okay, through LED and these resistances. So how we go about that? So see, the resistance is connected here. So what I can do is we will make connection to 3 different pins here. So we will be using the 11th. Okay, this pin, this 11th pin here. Okay, then at this terminal I can use one more pin, the 10th pin. Okay, the 10th pin is connected here, and here we need to connect the, suppose ninth pin I can connect. Could you connect this much, everybody?
Yes, ma'am.
Okay. So 3 connections of the LED are done, but there is one connection which is still pending, the cathode terminal of the LED. Okay. So that cathode means we need to connect it to the ground. Okay. Where is this ground? This one. And I can easily make it black color. Clear till now?
Yes, ma'am.
Okay, so this is all about your circuit to be like made for making the temperature sensor. This is very easy, just drag and drop and connect the wires. Okay, next thing is we need to go for the code section, like block coding will do. So there is this code here. All of you just enter click this code. So you can see that in this drop down option you get this either block plus text and text. So obviously the easiest one is blocks. We'll go for the block type like coding. So whatever is there by default, just put it in the bin. Just drag and drop and put it in the bin. Okay, clear till now? So we need to now design this thing in the coding block coding section. Clear? Shall I move ahead?
Yes, ma'am.
Okay, next. So the first thing you can see in the block section, there are 6 different headings. One is your output, input, notation, control, math, and variables. So just click each one of them and see what is there inside. So this is outputs. So outputs means the set built-in LED to high. So this is output means your LED display what how it will behave that you can like select from here. And here this is the input section. So input section means read temperature sensor to pin. We are reading from pin A1, so we'll make it pin A1. There is this notation. Then notation means the heading of the code and all those. So this is just for your understanding. The control, you have your like the different conditions. If then else, if else conditions are there. Then this math variable. Math variable means you can is like that if temperature is above this much, this greater than less than all this will come under your math. And then the variables means acha, can you tell me what is the variable here, anybody? What is the deciding parameter in this experiment? What will help you
The
understand?
V out that is coming out from temperature
Temperature,
sensor.
temperature.
Yeah, the V out is nothing but your temperature. Okay, because that is the output of the sensor, V temperature sensor. So that is your temperature. So what I can do is just click on your variable and go to this create variable. Okay. Did you all get this window? Are you all getting this window?
Yes, ma'am.
Okay. So I'll give the name as
But ma'am, the
temperature.
V out that we get is temperature, or we have to map it to temperature?
We have to map it to temperature.
Yes, ma'am. That's what I'm saying. That is V out.
That is V out, but it has to be, we will be, since experiment wise, we have to map it to temperature. So this is all about the temperature greater than this much and all. So
Okay.
what
You
we
said
do is,
temperature. That's why I was confused. Okay.
it has to be like, it since now, okay, anyway, that it has to be temperature. Okay, because we'll ultimately map it that way because we will, whatever conditions we'll design this experiment for, it will be based on temperature. Because what, if it is greater than this much, then this, if it is less than this is this. So just give the name as temperature. Okay, and click OK. So now you have your variable here. Is it clear? Are you all getting these things? So all of them are of different colors, just to help you like differentiate all those things. Did you all create the variable?
Yes, ma'am.
So now go to this
Yes, ma'am.
notation section. Okay, just go to this notation section. So there is this title block. So I can just drag and drop here, and the comment block. That also we can simply drag and drop. So what is the title block comment? So what is the title you can give? That is health monitoring. Yes. You can give. Okay, or you can give experiment one also, doesn't matter. So this is just for you to understand that this is the title of the experiment. Okay. Then comment means what again I'm simply giving using temperature. Anything you can give, doesn't matter. Okay. So this is the title and this is the comment. Clear till now?
Can you just show how to create the variables? I was making the design of the circuit.
Okay, this variable, just go to this variable, there is this create variable option. Okay, everything will be blank for you because you have not yet created, just click that create variable. Then this window pops up, just write down temperature and press OK. Clear?
Yes, ma'am.
Okay, just quickly finish up, then we'll move on.
Ma'am, after
So,
creating variables, after that, what am I supposed to do?
there is this notation section. Okay, so I simply dragged and dropped both of them. One was your title block, one is your comment. So title, anything you can give. I have given health monitoring. The comment is using temperature.
Okay,
Okay,
ma'am.
this is just for you to understand when you open the experiment or the block. Okay.
Okay, ma'am.
Then go to this input section of the one. Okay. Just go to this input section and see. So see this last one. Read what you are doing basically. Read temperature sensor on pin. This I need. Okay. So what I can do is this I can simply drag and drop here. Okay. Just a second. Okay. I'm simply removing this. So first thing is this I'll use. Okay, the variable is temperature. So what I'll do is you can see this variable section. There is this set temperature too. So what I'll do is I'll simply drag and drop here. Just see. The moment you drag the block, just see that popping sound comes up. Okay, that popping sound, if it comes, it means it is properly placed. Okay, so now just go to the set temperature to, I simply click something. Okay, I dragged and dropped here. Okay. Next is, where is this? You are setting the temperature to what? The ones like you told, it has to be mapped to the temperature. From A1, whatever you did, that has to be mapped to the temperature. So what you need to do is, that has to be read temperature sensor on pin A. So this 0, I'll just overlap it here. Okay. See, the pop-up sound comes. Are you all getting this? I simply did set temperature to something was there. To that something I did, I pasted that read temperature sensor on A1 pin. Okay, this is A0 pin. So what I'll do is I will make it A1 because in my circuit I have A1 and the unit is degree Celsius or degree Fahrenheit. Okay. So you can choose any one. I'll just tell you to keep degree Celsius because I'll tell you why at the end. I'll tell you why I chose degree Celsius. Okay. So is this clear till this much? What I did? Set temperature to read temperature sensor on pin A1. Is it clear?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, next. So next is we have taken the temperature as per our algorithm now. We have taken the temperature from A1 in degrees Celsius. That's what we have taken. Now you need a comparison. So comparison means obviously your control that if then condition has to be checked. So what is that if then condition? This one. I'll drag and drop here. Okay. There are, I'm taking three conditions. I'll tell you what are they. Just check the popping sound once you place. If it is properly placed, that pop-up sound will come. Okay. Next. If first thing is if temperature is less than 36 degrees Celsius, then the LED will glow some certain subtle color, say yellow or pink or whatever. That means there is no temperature at all. So what I'll do is, so here I need, if something you have to check, what is that something? Something is temperature is less than 36. Okay. So temperature is what? Your variable. So you have to check this one. So you need less than operation. Less than means you need mathematical operation. So where is that less than operation? Can you see it in this math section? One is that plus, one is less than. There are different examples. So I can directly select this less than thing. Is it clear why I am selecting this one? Because
Ma'am, I
I
think
need.
your screen is frozen now.
Okay. Is it not? Can you not see my screen?
It's
No,
frozen.
ma'am.
Okay.
It's stuck on variable still.
Okay. Okay. Let me stop sharing. Okay. Can you see it now?
Yes, ma'am.
Okay. What I did is I'll tell you what I did. Did you see that I took these three conditions? This if then
Yes,
if then
ma'am.
if then. So next.
Yes, ma'am.
I need a mathematical control. What is that mathematical operation I need to do? My temperature has to be compared with some parameter. So it has to be set checked if it is less than or greater than. So in this math section, you see there are different operations. One of them is your less than. So this operation I can simply drag and drop here. Check that popping sound when you place. Okay, so there is this hexagon thing. So there it has to be placed, and if you place that popping sound will come. Okay, in three cases I have simply pressed that. Is it clear till this much?
Yes, ma'am.
Yes, ma'am.
Okay, so first condition is here what I need on the left hand side, there has to be the variable temperature on the LHS. So where do I get the variable from? Here. Okay, so the temperature is here. What I'll do is I'll drag and drop that on the LHS. Just do it and check the popping sound every time you place. Okay, the popping sound indicates that it's properly placed. Now is it clear till this much? Clear till this?
Yes, ma'am.
Okay, so the first condition is if temperature is less than, here I let it. So I'll check 36. If temperature is less than 36, then what has to be done? Just check. What should be the output? Just check in the output section. This last one, set RGB LED in pins. So what I'll do, there is this white color section gap here. So I'll place it over there. Okay, so I'll just place it over in three cases, all the three cases. Check the popping sound every time you place. Okay. Okay. Now see what is my situation. So now the condition is if temperature is less than 36, then set RGB LED in pins number. What are the pins number in LED? 11, 10 and 9. That's the three pins we have used, right? Yeah, you can see, right? We have used pin number 11, 10 and 9 in the circuit. Hello?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
so just make it 11, 10 and 9. Okay, these three pins to a certain color. So now since it is like less than 36, it's not nothing to be worried about. You can make it any subtle color like yellow, sky blue, whatever you feel like. Okay. Next is if temperature is, what I'll do is temperature is suppose greater than equal to 36. What I'll do is temperature is greater. So again the pins are again connected to pin number 11, 10 and 9. Okay. And then this color is suppose I want to make it greater than 46, suppose orange color or suppose blue color I make it. There's no difference here. Okay, so if it is greater than 36, greater than equal to 36, it will be blue color. And next is if temperature is greater than 38. Okay, I make it 38. 38 means heavy temperature. So pin number again 11, 10 and 9. Okay, the LEDs are connected that way, so we made it that way. So just make it to red color. Is it clear till now?
Yes, ma'am.
So that's all about our circuit block. Okay, entire block. So just see what we did. The title and the comment is like optional. Then we did set temperature to what you set the temperature to. It is mapped to sense pin A1 in units it's degree Celsius. Then we just checked three conditions. If temperature is less than 36, then the LED will glow yellow. If temperature is greater than equal to 36, it will glow blue. If its temperature is less than 38, it will glow red. Okay, this is the simple like if then condition we used. So that's all. So next is you can go to this simulation section.
Ma'am?
Ma'am, I got the last else, ma'am, after third if.
You have taken, you might have taken this one, I think. Did you take anything like this?
Okay,
I
ma'am.
just took this simple block. You might have taken the other ones. Okay. I took this one. If then, I took this one. Okay. And you might have taken this one, I guess. If then else. Can you quickly rectify that?
Ma'am?
Okay. Then, yeah. One more thing is, if you want, you can use that also. Okay. Just if it is greater than 36, again, you check. Like if it is again less than 38, if else condition anything, any logic you can use. It is not mandatory that this, you have to use this one only. Yeah, tell me. Somebody is telling something.
Ma'am, for temperature 39, won't the second and third both conditions be satisfied? Then what color will come?
Yeah. That's what I told. Like we'll see how it performs. Okay,
Yes, ma'am.
because in the 39 both the conditions are satisfying. So if you want, you can edit here that if it is greater than this and less than this. But in math, I don't think there is that option. Okay, there is not that option that okay this and this. Okay, this one we can use. Okay, anyway, let's just experiment now. We can also edit this one. Okay, the temperature is greater than this and this. Instead of 36, we can put it here. Okay, something again, one or two more operations we need. Is it clear? This basic, this is the simple thing. Okay. Okay, so there is this start simulation thing. Just go to this start simulation. Okay, just remove this code here. You can see the LED here. The moment you click this temperature sensor, just see that. Okay, zoom. Let me zoom. Okay. Okay, so this temperature sensor, see, there is one like, I'll tell you. Okay, so see, here, uh, are your LEDs glowing, everybody?
Yes, ma'am.
Yes, ma'am.
Okay, you can see my mouse settings. Okay, just check one thing. Yeah, in this temperature sensor, there is the slider appearing. Okay, this is starting from -40. So just see as the temperature starts increasing. So if it is less than 36, it was made some color. The moment it reaches 36, there is this change in color, 36 to 38. Okay, just see 36 to 38, the color changes, and after 38, 39 degree, it is becoming red. Okay, so just notice, are you all getting the same color whatever you have given in the blocks, or you are getting some different color? Just cross check that. Have you given after 38 it is red for everyone? So is
Yes, ma'am.
it, are you getting exactly same color whatever you have given in blocks,
No,
or you are,
different.
is anybody else also getting different color?
Got the same, ma'am.
Okay, so like some of you might get different color. Actually, this problem I am also facing. So I googled that. So there are so many blogs related to this. You can also see. So it's a like there's no I couldn't like land up at any conclusion for that because there are all questions appearing on this, but there is no response I could get. So like some of like there are so many questions. A lot of people have faced this problem. So if anybody gets an answer to this, because for every system it is not happening, but in specific like some cases it is happening. Like you get a different color. Just check that your colors are changing. That's all. Okay. For the timing, just check it that way because some of you might get that error. Now I have a some color. If it is 30 after 36, it is a different color. After 38, again it's a different red color. Okay, just cross check this much.
Ma'am, the LED is not glowing.
Is your connection proper? Just send me the snapshot of your connection and block them. Okay,
Yes.
just check everything or else just send me the snapshot. Check if your power supply and ground are connected properly. Is everybody able to run this? Are you getting a temperature sensor like working properly depending on the temperature? Okay till now? Okay, so what I'll do is just go to this code section. I will just ask you to modify a little bit. As one of your friends suggested, can you try editing this? Okay, that we'll do next. Just this unit is in degree Celsius. Just try making it Fahrenheit. Okay, Fahrenheit, make it, try to make it. So here the values will be 98.6. Okay, because normal temperature is 98. So like if it is below 98.6, it is normal. From 98.6 to suppose 100, it is okay, little temperature, and above 100, it's high temperature. So can you check that condition? And I know there will be some issue, so just try that, then I'll tell you what is the issue. Just try this much. No need to check if then all that now. Just check 98.6, more than 98.6, more than 100. These three conditions, just check. Can you quickly do that, everyone? After you are done, just stop, try to stop simulating. If you don't stop it, you won't be able to edit and do. Okay. If somebody wants, you can put a buzzer also. Okay, along with the LED. If the LED is glowing red, you can put a buzzer along with that. Okay, there's so many variations like possibilities here. You can go about doing all those. Yeah. Are you trying that Celsius Fahrenheit thing? Hello? Hello?
It is still showing in Celsius only, ma'am.
Yeah. You changed it to Fahrenheit, but still it is showing in Celsius. That's what I was telling. The glitch is only because the sensor which you are using, this TMT36. Okay, just Google. It is a Celsius based sensor. Okay, you cannot use it for Fahrenheit. Just check temperature. That name you are using TMT36, right? Here, just check.
Yes, ma'am.
Okay, that name is TMG36. Just Google about that sensor. So it's a Celsius measuring sensor. So that's the reason you won't get in Fahrenheit. If you want in Fahrenheit, you have to use the like a different sensor, not this particular sensor. Okay, and just try experimenting. Can you try this one that instead of this one that somebody suggested that if it is like 39 both the cases satisfy, so try to put in here two cases like temperature is less than 30, greater than 36 and less than 38. Okay, this is for you to try and see how it performs. So what you can do is just try to use this one. Okay, so this one instead of this. Hello.
Ma'am, when we change it to Fahrenheit, the conditions get changed, but ma'am, it's still, even though it still shows centigrade, but the conditions get changed.
98. The values are 98.
No, ma'am, I'm saying when we change the Celsius to Fahrenheit,
Mhm.
the conditions get changed according to that.
Yeah, conditions will change, but in
it
the
still
scale,
shows, yes,
in the scale it will be Celsius only.
yes.
Okay, the values will change, but the unit is again Celsius here because that automatically is a Celsius measuring device. So one more thing is just try this one. Instead of just putting 36, you can use this AND operation here and experiment on them. Okay. So this is the simplest of all the experiments, the patient health monitoring. This is a very easy one. So this is all about your first experiment. I'll see what we'll do in the next experiment. There is something called Panda. We need to install an Anaconda and all. So I'll give you, like, if we go for that, I'll let you know. I'll ask you to install that. Let's stop sharing. So that's all for today. So is there anything you people have to ask me?
Attendance, ma'am.
Yeah, I'll give the attendance. Okay, just let me post the question.
And we have to take screenshots of the result for like making the file.
Yeah. Net screenshots of the result.
Okay.
Ma'am, whatever we did today is only experiment one, or is there anything else that should be done?
No, just try to add that if then that condition, whatever I told you, like one of your friends suggested, that's all.
Okay, ma'am.
Just giving the question, you can post it. You can post the answer and then you can. Yeah. Yeah, Hannah, you had sent me. I didn't see. I think Vinayak has already replied you. Your problem is solved, right?
Yes, ma'am, I corrected it. Yeah, I corrected it, ma'am.
You didn't remind me. I also forgot to ask you again. Okay, anyway, it's not. So everybody could complete this set of experiments, right? This entire first experiment. Anyway, 16th, okay, I'll let you know. If I have exam duty, I'll let you know. Okay. I don't know, like, if the exam duty is there, I'll have to cancel the class. I'll let you know. Okay. Those who have answered can leave. Thank you. I'll stop recording the session and end the meeting.
Thank you, ma'am.
Thank you.